All right, logicians. In this video, I want to show you how to use an indirect truth table to determine the consistency or the inconsistency of two statements. So here are my two statements. And when you are testing for consistency, two statements are consistent with each other if and only if there is at least one line of the truth table where both of them are true. So here's the main operator for this one. We've got a conditional. And here's the main operator for the other one. We've got a wedge. And if these are consistent, then there's got to be one scenario in which they're both true. So let's try to figure out which of these is going to be the easiest for us to start with. Now, there's three different ways for a conditional statement for a horseshoe to turn out to be true. There are three different ways for a wedge to turn out to be true. So this one's going to be a big pain because we're going to have to work through at least three lines of a truth table in order to figure out whether they're consistent or not. By the way, I made up this problem right now, so I've never worked it before. So we'll see how it goes. All right, so it's arbitrary, I think, which I start with. Let me start with the wedge, just for kicks. So one way for this to turn out to be true is for not Q to be true and for S to be true. Another way is for not Q to be true and S to be false. And a final way is for not Q to be false and S to be true. Now, if this is what not Q is, then Q itself is going to be false, false, true. So let me plug in these values. On line one, we've got Q is false and S is true. And let's plug that in now to this statement and see what happens. So if we know that Q is false and S is true, then that means that the wedge here is true. We've got one true disjunct. And if the stuff in parentheses is true, then this wedge is true. And if this wedge is true, then that means that the negation is false, because it's the negation of all of this. So if the negation, if the antecedent of a conditional is false, then what do we know about the conditional? That's right, it is true. Now, good news, I hit the jackpot. I've already won. The first line I tried showed that these are consistent with each other, right? Because here's a set of values for which, no matter what P and R are, it doesn't even matter. If Q is false and S is true, then both these statements are true and it's consistent. And that's really all I need.